Hi, so I'm Mohit, I'm from UCLA. I'm going to talk about real-time prefix hijack alerts, and this in particular I'm going to talk about this system called a FAS, prefix hijack alert system, that we have been designing at UCLA. There's an interesting little bit of history behind the name. My first name that I came up with for the system raised quite a few eyebrows, and I only realized a little bit later why, because I decided to call it prefix hijack alert in real time, which acronym to PHART, and that didn't make quite a selling point there. So we decided to call it FAS instead, and that's what we have right now. So there are three things. For one, this is a lightning talk, so I'm not going to go into a lot of details about the system, just a high-level overview and what the basic philosophy is. There are three things we identify for a security solution for prefix hijacking. Again, prefix hijacking, I'm assuming everybody knows it. First, you need to see the bad information, the hijacked routes. Second, you need to be able to distinguish between the good and the bad, that whether it is hijacked or whether it is genuine. And third, you need an incentive to fix the problem. Current data collectors like RIPE and RouteViews, we believe, have property 1, which means they can see all the bad information or most of the bad information. Prefix owners, on the other hand, can know what is good and what is bad because they own the prefix and they know who's announcing it. Also, they have the incentive to fix the problem. So key here is to combine all three at one place, and that's the idea of FAS. What we do is we collect updates. We actually look at updates from RouteViews and RIPE. These are the existing monitoring projects. And we maintain these origin sets. So anytime we see these origin set changes, that is an event for us. So that's for each prefix, of course. And then we send this report to the prefix owner. So what we are doing here is monitoring the origin sets for each prefix. And every time we see origin set changes, that is a new origin added to the prefix or an origin removed from the prefix set, we send a notification. Again, the philosophy is it's not really our problem to know whether it's a false origin or not. We send it to the prefix owner and let him deal with it. This is kind of the main components of FAS system. We have the origin monitor, which looks at RouteViews and RIPE updates and decides on how the origin set changes. From the email registration, we see the guys who are registered to receive notifications. We use email delivery to send notifications, and I'll touch a bit in a little bit. I'll touch on what the email delivery constitutes. Finally, since we do not distinguish between false origins and true origins, we allow this kind of filter block at the prefix side, which can filter out alarms that are not really important to you. For example, if your origin set is changing a lot, then you can just put in simple rules. Again, I'm not going to go into the details of this, but you can talk to me offline, and I'll be happy to discuss with you. This is an example of how the origin monitor works. As a simple example, prefix in question here is UCLA prefix. It's a /16. You can see right here. Let me see if I can find my. Okay, right here. So you can see this. This is the genuine origin. Some other ISP sees a new origin. As a result, the origin set, which was 52, now becomes 52 and 110. So the first instance of a new origin coming up changes the set. And this generates a trigger notification. We look up the prefix in our table. We see these are the email addresses registered. And I'll explain in a bit why we need so many email addresses. Actually, we don't need it, but we recommend. A message delivery is critical because if your prefix gets hijacked, there is no guarantee that I can actually reach you via email. So what we do is not guarantee the email delivery as much as increase the reliability of the delivery. So what we recommend is you should, as a prefix owner, you should have 2 prefix blocks or 2 emails from different prefix blocks that you have to register by. Also, in addition to this, you can register using public emails like Hotmail, Yahoo Mail, or Gmail, etc. And we have this local notification filter which would combine all these and send you just one instance of every notification. So you won't really receive duplicates of the same notification. At the same time, you can apply your filtering rules here to filter out some alarms. The key here is that we expect, due to the topological meshness, the hijacker cannot hijack all the routes that we try to take. And simulation results are obviously always good. So Here's a quick evaluation on what does this mean to you as an AS. This is based on data from December 2005. What we did was we picked up the routing table, the entire routing table, and mapped all the prefixes to the last origin as the prefix origin map. And we saw how many notifications we see. So there are a few cases where you see lots of notifications, and again, they are very similar. So this origin set is unstable. It keeps fluctuating, but it's only between 2 or 3 states. It's just too frequent. But in most cases, as you can see right here, let's see about around here, the number of notifications that you expect per month is less than 10, unless, of course, you do see origin hijacks, in which case you will get a notification. The key advantages of this system, it is readily deployable. We have a plan to get this actually up and running with a website so people can register. We just use route views and ripe data, so we don't need an AS to really change anything from them. We don't rely on cooperation from other networks, or in other words, the hijack detection is centrally done. Monitors, we do not need the input of from the ASs telling us what the real origin is, since we are just pushing out all the origin set changes and let them decide how to use that. Again, all emails sent by us would be authenticated, and since it's a single source of the emails, the authentication is not that much of a problem. Finally, we have a low overhead for deploying the system. I'm up on my last slide right now, which summarizes what we have done and what we have planned for the future. So the first thing is we have looked at data from archives and have a thorough performance evaluation on the system. We have caught some known hijack events that have been in the past. We are in the process of developing a real-time system or near real-time system, which would maybe operate with a lag of 2 to 3 hours. The bottleneck here is how fast you can collect data from route views and ripe, and that is pretty good actually. If you're interested in receiving notifications, you can send us email and keep in touch with us. We expect to get the whole thing ready pretty soon. And the ongoing efforts also involve a couple other different types of hijacks. One is a covered prefix hijack. So it's not the exact prefix, but a sub-prefix of yours is announced that is also covered in that. And finally, we also have this notion of a false last hop. So the prefix might be registered, and the origin might be same, but a guy is announcing a false hop to that origin AS. So that can also be detected. If you're interested in more details about how the system intricacies, then you are encouraged to go read or ask us about this paper we have, which will appear in Usenix Security pretty soon. And that's about it. It's a quick talk, so I think we have time for questions.
Danny McPherson, I just have one question actually, and I think you're probably touching on it with the false last hop thing. Is that associated with the origin AS and the fact that the origin AS could be spoofed, and most people that even do prefix filtering don't look at a combination of AS and prefix, they simply look at the prefix, and so if it's registered. So could you expand on what you're doing to try and obviate some of that?
So we are going to do the false last hop based on origin AS, not so much the prefix. I'm not sure about the origin AS being spoofed. Is that what you...
Yeah, so for example, if I want to hijack someone's prefix and I know that people are looking at the origin AS, all I do is insert an AS in there and as the origin AS of this prefix when I hijack it, and it gets around all these systems. And so you got to do something to watch that as well, right? And so that's my concern with these kind of alerting systems is if anyone has even a bit of clue about this, they just simply insert whatever the legitimate origin AS is, because the control plane data is completely orthogonal to the forwarding path anyway, so it doesn't really fix that or alert on that.
So if I spoof, let me just get a question right. So if I'm AT&T, for example, and you want to spoof my route, so you're saying you can say that you are AT&T, is that what you're saying?
I'm saying that when I send an update, I would say this is coming from AS 7018 or whatever the AS I'm concerned with is, and nobody's going to look at that, and so there's nothing to stop that, and so the forwarding path will change, and the AS itself really doesn't matter.
Okay, so I think we need to think about this question in more detail. I don't have an immediate answer to you, but I can talk to you offline about this thing.
Okay, thank you.
Thanks.